Imagine trying to lay down train tracks in front of a moving engine. You can see the train coming, you can gauge its velocity, and you generally have time to build the infrastructure to guide it safely. But what happens when that train suddenly turns into a rocket?
And the people laying the tracks are moving at the speed of, well, a walking tree.
Exactly. Welcome to episode 534 of AI Brief. I am your host, and I'm joined by my co-host to bring you today's deep dive. We are unpacking a series of developments that show an industry stretching the absolute limits of physics, finance, and the law.
It really is a wild time. We've got so much to cover today.
We really do. We're exploring Anthropic's urgent, almost desperate warning that AI is massively outrunning regulation. We're also looking at Elon Musk's super ambitious plan to escape Earth's power grid by literally launching AI data centers into orbit.
Which still sounds like science fiction.
It does. And finally, we'll examine why OpenAI is tying its massive upcoming IPO to the arrival of self-improving AI.
The developments today present this fascinating paradox. We are watching the frontier labs simultaneously try to slow down the regulatory clock on Earth, while literally launching their hardware into the vacuum of space to escape physical constraints entirely. The tension between terrestrial limits and orbital ambition has, well, it's never been more apparent.
Let us start by looking at how the biggest players are managing the sheer speed of advancement. Anthropic CEO Dario Amodei just published this huge, comprehensive new essay titled Policy on the AI Exponential.
Oh, this is the one with the Lord of the Rings reference, right?
Yes. He opens with this brilliant analogy. He compares Washington regulators to Treebeard, the talking tree whose pace is so incredibly slow that simply saying hello takes all day. Amodei is basically arguing that the lightning pace of the industry requires policy to stop moving at tree speed.
Which is a pretty bold way to address the people you're asking to regulate you.
Definitely. But he points specifically to the Claude Mythos preview as the catalyst for this. He argues that the hacking risks they observe there represent a major turning point.
The urgency scaling from Anthropic right now is palpable. In the past week alone, they put self-improving AI on the clock and released their most powerful model.
And now he's calling for independent screening systems.
Exactly. When Amodei calls for independent screening across 4 distinct risk areas before frontier models can even be deployed, it suggests that internal red teaming is revealing capabilities that cross the line from theoretical concerns to immediate actionable threats. These models are now tools of national strategic consequence.
And to manage that consequence, he wants regulators to have the unprecedented power to literally ground frontier models, like full stop. But the essay goes much further than just model deployment. He outlines a comprehensive jobs framework designed to plan for unprecedented unemployment.
We're talking about universal basic income, I assume.
UBI is definitely in there, which is a familiar talking point, but he also proposes creating public investment accounts populated with actual shares of AI companies to distribute the economic gains. Plus, he is demanding faster approval for AI-designed drugs, strict bans on autonomous weapons, and much stronger advanced chip export controls.
The scope of that proposal is staggering because it treats the economic fallout and the security fallout as two sides of the same coin. Distributing shares of AI companies, for instance, that's a direct acknowledgement that traditional wage taxation just won't be enough to fund a safety net if capital completely decouples from human labor.
Okay, but this brings up a critical question for you, the listener. We have a dominant market leader essentially begging the government to regulate them harder. Is this a genuine plea driven by terrifying internal benchmarks, or are we looking at a classic moat-building strategy?
That is always the million-dollar question with tech regulation.
Right. It is incredibly common for a dominant tech company to try and pull the regulatory ladder up behind them. If you create compliance barriers and independent screening processes that cost tens of millions of dollars, smaller startups simply cannot compete before they even buy their first GPUs.
Skepticism regarding regulatory capture is always warranted when a market leader asks for government intervention. You are absolutely right to point out that high compliance costs act as a massive structural moat.
It's the perfect defense.
It is, but Amodei has been sounding this specific alarm for a considerable amount of time, well before Anthropic possessed any sort of market lead. Furthermore, the plea to give the government the authority to ground frontier models is a massive concession of corporate power. It is hard to view that purely as a cynical business play when it directly threatens their own product roadmap.
That's a fair point. If Amodei gets his wish, and Earth-based regulations make deploying compute too slow and cumbersome, it suddenly makes perfect sense why someone like Elon Musk is looking to escape Earth's jurisdiction altogether.
It's the ultimate regulatory workaround.
Moving from these terrestrial regulatory battles, we pivot to a physical energy battle happening overhead. SpaceX just provided the first official preview of AI-1. This is a solar-powered satellite specifically built to run AI chips in low Earth orbit.
Bypassing the terrestrial power grid is a radical but highly logical solution to the massive energy bottleneck facing the entire industry right now.
Because building on land is just taking too long.
Exactly. We are seeing local zoning battles and grid capacity limitations severely throttle the deployment of compute on Earth. Getting a new power substation approved can take years. Capturing unfiltered solar radiation in a vacuum entirely sidesteps the geopolitical and infrastructural red tape of land-based data centers.
And the hardware approach is just fascinating. Elon Musk detailed that each satellite will possess as much computing power as one of NVIDIA's top-tier server racks.
Wait, an entire server rack in one satellite?
Yes, the computing equivalent of a full rack. He noted that the AI-1 craft is actually much simpler than a Starlink satellite. They are trading super complex communications antennas for a streamlined system of massive solar panels and, critically, giant radiators.
Because space is cold, but it is a vacuum.
Precisely. There is no air to carry the heat away. So managing the immense thermal output of an NVIDIA server rack in orbit requires beaming the heat away with radiators and then using lasers to beam the data back to Earth.
The thermal dynamics are exactly why this was considered impossible for so long. But SpaceX plans to design the craft modularly, meaning they can send up missions to swap out which chips go inside over time.
So they don't have to launch a whole new satellite just to upgrade the GPU.
Right, it allows for hardware upgrades without replacing the entire craft.
And they are building the physical footprint to scale this rapidly. SpaceX's planned Bastrop factory could cover over 11 million square feet, with AI-1 production aggressively targeted to begin before 2028. But what really stood out to me is the customer list. Google and Anthropic have already signed on as orbital compute customers.
That industry adoption is the most telling metric here. It represents a monumental shift, effectively challenging the previous verdict from Sam Altman, who not too long ago dismissed space-based data centers as ridiculous.
He really did. He thought it was a joke.
The fact that two major frontier labs are committing to this shows that AI-1 is no longer just a theoretical moonshot. It is a highly viable manufacturing plan to solve the immediate terrestrial energy crisis.
Speaking of escaping limits, let us bring the conversation back down to earth and look at how OpenAI is trying to escape traditional financial downs. Internal Slack messages sent by Sam Altman to employees indicate that OpenAI plans to go public within the next year.
Oh wow, so they are officially making the move.
Yes, and this follows a draft S-1 filed with the SEC earlier in the week, putting them right on the heels of Anthropic's own recent SEC filing.
The timing of these dual IPO filings is not a coincidence. Both companies are realizing that the private venture capital markets simply do not have deep enough pockets to fund the next generation of infrastructure. They desperately need the liquidity of the public markets.
But here is where it gets really interesting. The most fascinating variable in this entire IPO equation is how Altman is framing the timeline. He suggested that if RSI takeoff, which stands for Recursive Self-Improving AI, looks close, it might actually be advantageous to delay the IPO.
Delaying it because the technology is moving too fast.
Exactly. The logic is to avoid rushing to the public market during a period of massive technological uncertainty. At the same time, we know Chief Scientist Jeku Pachoki reportedly told staff that a new model codenamed 5.6 is coming this month, which is a meaningful improvement over their flagship GPT 5.5.
Tying the precise timing of an initial public offering to the arrival of recursive self-improving AI fundamentally changes how the financial world must evaluate these companies. It proves that the frontier labs are treating self-improvement as a tangible, near-term business variable.
It's not just a sci-fi pitch anymore.
No, think about what RSI actually means for evaluation. You are no longer valuing a traditional software company. You are trying to value an automated R&D lab that can write its own code and optimize its own architecture.
I have to push back a little bit here, though. Are we sure Altman isn't just using the promise of self-improving AI as a shiny object? I mean, we know they're weighing infrastructure requirements that may require hundreds of billions of dollars in financing. Could the RSI narrative just be a convenient way to justify delaying an IPO while they frantically figure out how to pay for all these data centers?
It is entirely possible that it serves a dual purpose. Maintaining the mystique of an impending superintelligence certainly helps maintain their leverage with private investors. But regardless of the PR strategy, the capital requirements are very real, and the timeline for public market entry is shrinking rapidly.
Which perfectly transitions us to what is happening on the ground right now. Because while the frontier labs are looking toward orbit and planning massive public offerings based on self-improving algorithms, they're facing immense friction with the models we actually have today.
We really are seeing significant friction across multiple sectors right now. I'll take us through a rapid-fire breakdown of these latest operational updates, starting with Anthropic's user experience. Anthropic is currently facing considerable backlash from users regarding their Fable 5 model.
What kind of backlash?
Well, there were widespread reports of the system constantly flagging and refusing queries related to biology, chemistry, and cybersecurity. It's actively restricting research.
This is the classic alignment tax problem. In their rush to make the model mathematically safe and compliant with all the regulatory fears we discussed earlier, they have implemented a hyper-vigilant safety guardrail.
Yes, and that guardrail is actively restricting legitimate academic and professional research.
If a biochemist cannot ask a complex structural question without triggering a safety ban, the tool just loses its enterprise utility.
Not precisely. And simultaneously, Microsoft is dealing with a different kind of internal friction regarding model deployment. The company is actively restricting its own employees' access to the Fable model.
Wait, restricting your own employees? Why?
The restriction is tied directly to a stringent corporate data retention policy, which requires all internal chats to be saved and reviewed for up to 30 days.
Oh, the corporate irony there is almost painful. Their own strict data retention and compliance policies are handicapping their ability to use the very AI tools they are heavily invested in.
It really shows how legacy IT rules fundamentally conflict with the seamless integration of generative workflows.
It's like trying to plug a spaceship into a wall outlet.
Speaking of wall outlets, looking at physical infrastructure, the scale of terrestrial compute continues its dramatic expansion. This highlights exactly why OpenAI needs so much capital. They are reportedly closing in on a 20-year lease for a staggering 10-gigawatt data center campus located in Ohio, potentially financed by NVIDIA.
We really need to put a 10-gigawatt campus into perspective for a second. 10 gigawatts is roughly the output of 10 nuclear reactors.
It is an unfathomable amount of power.
It is enough energy to power several major cities. This is a $500 billion project. The sheer physical footprint required to train and run these models is scaling up with an intensity that matches the software's digital footprint.
And while that massive scaling happens on the hardware side, in the realm of open source development, Google has released an experimental model named DiffusionGemma. This model takes an entirely different architectural approach to text generation.
How so?
Most modern systems are autoregressive, meaning they predict and generate one word at a time in a linear sequence. DiffusionGemma generates text in parallel chunks, processing 256 tokens simultaneously.
So think of traditional AI like a vintage typewriter striking one letter at a time, moving left to right. DiffusionGemma is more like a traditional printing press, stamping down an entire 256-word page in one singular motion and then refining it.
That is a great analogy. This architectural shift quadruples the output speed, hitting over 1,000 tokens per second on a single NVIDIA H100 GPU.
That speed is an absolute game changer for applications that rely on instantaneous, real-time results like live translation.
Finally, we're observing deepening cultural friction within the entertainment industry. The Art Directors Guild has issued heavy criticism against the legendary director Martin Scorsese, who recently accepted an advisor role at the AI startup Black Forest Labs.
The Guild accused him of turning his back on human artists, right? We're not taking sides here, but this confrontation perfectly highlights the escalating tension between traditional creative guilds, who view this technology as an existential threat to their livelihoods, and the rapid, unstoppable advancement of generative video and image tools in Hollywood.
It is the human element of the friction we are discussing today. Whether it is regulatory policy, corporate IT rules, or creative guilds, the existing societal structures are straining under the weight of this technological acceleration.
Let us translate all of this high-level infrastructure and cultural friction into the practical software layers that you can actually use today. The $500 billion investments ultimately trickle down to the tools hitting your desk. I'm going to walk through today's trending AI tools, but instead of just listing them, let us look at the overarching themes they represent.
The firfirst major theme we are seeing in these tools is the push for enterprise trust and execution. This is really about making AI reliable enough for core business operations.
Right. And Cube is a perfect example of that. It provides embedded AI analytics that operate through a strictly governed semantic layer. The practical use case here is deploying AI-driven dashboards directly to your clients without the constant fear that the system will hallucinate financial numbers.
Because the semantic layer ensures the AI only pulls from verified, predefined data definitions.
Exactly. You also have Poetic in this category. This is a highly adaptive AI designed for enterprise software that learns your specific business procedures by watching you work.
The incredible use case with Poetic is its self-healing capability.
Yes, the self-healing is wild.
Think about your own workflow. When an underlying application updates its interface and moves a critical button to the other side of the screen, traditional robotic process automations break entirely.
They just fail because the pixel coordinate changed.
Right. But Poetic understands the actual intent of the workflow, so it visually hunts for the new button and self-heals the automation instantly.
The second major theme we're seeing is the widening divide between local versus cloud execution. On one end, you have the massive cloud power of Google's DiffusionGemma that we just discussed, perfect for lightning-fast, real-time generation. But on the other end, you have tools like Siri AI. This is Apple's newly overhauled on-device assistant.
Apple's approach proves that the industry is fracturing in how it handles processing. Because Siri AI processes information directly on your local hardware rather than sending it to a cloud server, it operates with essentially zero latency.
And it solves a lot of those corporate IT issues we talked about with Microsoft.
Exactly. It can securely read your screen and integrate deeply into your local apps to perform multi-step personal tasks, keeping your data entirely private.
Moving to our third theme, we are witnessing the rise of true autonomous agents. We are moving past AI acting as a simple chatbot and into AI acting as an independent auditor and executor. CounselAudit is a brilliant example of this.
What does CounselAudit focus on specifically?
It is a highly specialized AI for the legal sector that systematically reviews every single line of a complex legal bill. Instead of a human lawyer spending hours looking for redundant billing, the AI automatically pushes back on overcharges, ensuring corporate legal departments stop bleeding capital through opaque invoices.
We see that same autonomous capability in software development with Codex. These are OpenAI's specialized coding agents.
They write the code for you.
More than that, if you are a developer utilizing Codex, you are no longer manually writing boilerplate code or hunting for bugs. You are essentially managing an automated assembly line, allowing you to build and ship products significantly faster.
And a tool called Youmake takes that assembly line concept even further. It is a platform that empowers you to build, deploy, and continuously run autonomous web applications. It serves as an end-to-end deployment tool.
So it handles the hosting too.
It entirely removes the friction of server management. You just focus on the logic of your application while the AI handles the entire hosting pipeline behind the scenes.
The final theme we're tracking is creative synthesis. Tools are consolidating to streamline production. Mova Studio operates as an all-in-one creative workspace.
Bringing everything under one roof.
Right. Instead of subscribing to 5 different niche platforms, you can generate video, craft images, compose music, and synthesize speech assets entirely within a single interface.
And Presentr Analyze complements that by automating the post-production side. You upload any audio or video file, and the AI automatically transcribes the dialogue, generates captions, translates the content into multiple languages, repairs poor audio quality, and extracts key text. It completely automates hours of tedious labor.
When you look at this entire software landscape, from CounselAudit meticulously reviewing legal bills to Poetic self-healing broken workflows, the evolution is undeniable. The technology is moving from a passive advisory role into a direct execution role. AI isn't just answering questions anymore. It's actively auditing processes and maintaining workflows without human intervention.
That brings us to the end of our deep dive today. I want to leave you with a final thought to mull over as you process the sheer scale of everything we just covered. If the computing power required to run the future of our economy is simultaneously moving into the vacuum of orbit while demanding $500 billion, 10-gigawatt power campuses here on Earth, we are no longer just participating in a software race. We have entered a full-blown infrastructure war. The ultimate winners in the next decade will not just be the ones who write the smartest code, but the ones who can harness the sun and the power grid the fastest.
Thank you for joining us on this exploration. Please make sure to follow the show and share this deep dive with anyone in your network who needs to stay ahead of the AI curve.
See you in the next